Okay, so we are going to talk about amino solutions for the PU polyurethane segment. We're always aiming at a circular economy and sustainability. My name is Tiago Oliveira. I am responsible for the Amino's technical lab. This is the agenda for this presentation. I'll first show you Amino's institutional video. Then I'm going to tell you about our divisions, our carbon footprint, sustainable solutions, renewable raw materials, the ecological blowing agent, and then we'll wrap up with circular economy. This is a video. If you could please play it. Tiago is saying, I believe the video has no audio. Specialized in research and development in the PU chain, 14,000 meters of total area. Operating in the automotive, furniture segments and others. With a personalized project for each customer. Raw material coming from certified providers from all continents. Test lab to develop new projects and products. We have a standardization assurance throughout our process. We've undersigned Kyoto Protocol. We work seeking technologies that are sustainable and according to the current standards. Very accessible and easy distribution. Our customers in Brazil and Latin America. Our vision and values. Okay. So these are our divisions. We have 3 divisions: additives, systems, and case. In each of them, we have different business units. In additives, we have catalysts, silicones, pigments, performance additives. In systems, we have the conventional flexible systems, HR, viscoelastic, hypersoft, semi-rigid, integral skin, microcellular, and rigid system. And then in case we have the coatings, BU, adhesives, sealants, elastomers, and special prepolymers. Carbon footprint reduction. So we have been doubling down on reducing our carbon footprint. From the middle of this year, we are going to change our energy matrix source. And we will start to use 100% clean energy. That change will happen in the middle of this year. So from the mid of 2024, all our plants will use 100% renewable energy sources. And we've been working on the production of polyols and products that come from renewable sources that will further help us to reduce our carbon footprint. Now, talking about our sustainable solutions, renewable raw materials. This is one of our values. We aim to use more sustainable, renewable raw materials to reduce the environment impact and the footprint, and we also would like to reduce the life cycle of the product after being disposed of. So we would like to reduce its length of stay in the nature and its impact in the nature. Amino has been using for a while now the ecological blowing agents. They have a very low GWP and nil ODP. In a while I'll tell you more about our challenges. Then we have the circular economy solutions. Amino has developed a range of solutions that seek to repurpose parts that, instead of going to waste or discarded in landfills and taking years to decompose, to break down, we can reuse these parts.
And now speaking about products that use renewable sources. We have the adhesive PU. The fossil sources polyols are replaced by renewable sources polyols. It's a multi-component system. And then we can use metal base, for example, as you see on the picture. So there was a better adhesion, and then we used vegetable source polyol. So diesel, it has a good resistance to oil, diesel oil, engine oil, and it has a great thermal resistance. Next. Well, this development was made with a major client, so we developed this system that used polyol from renewable sources. So we reduced the use of fossil source polyol. The blowing agent was ecological as well. And for this application, we reached the properties that we desired. The molded density for this application is 34 to 40. Reactivity was kept for this application. It is a product that has a low K factor below 0.022, flammability at level R1, and it has a great dimensional stability that is smaller than 1.5%. The semi-rigid packaging system. So in this development, we replaced 100% the fossil-based polyol by renewable source polyol. We used the blowing agent water only, and the properties, they were excellent. A great dimensional stability, free density between 10 to 12, and we can mold at 20-25 density. It has a good fluidity and a good filling of cavities, and the final part with an excellent finish. We know that the service life of a packaging is short. It is disposed and usually goes to the landfill and it pollutes our planet. In order to solve that, we then simulated the disposal in a biodegradable environment as if it were a landfill. This was done in a laboratory. And then the part was submitted to a biodegradability test in a fully degrading environment. And the partial results are quite positive, by the way. And then we'll aim at reducing the environmental impact of this final product after its disposal. So the service life of this product after disposal is reduced. It is an excellent product, therefore, especially for a product that has a short service life, because you use whatever is inside the packaging and then the packaging is thrown away. By using this system, we are able to be friendly with the environment. This is possible. Next. The HR system for automotive seats and backrests. Well, the automotive sector always aim at using sustainable materials from renewable sources. So we developed this system that replaces most of the fossil-based polyol by renewable source polyol. So the system was developed with a water base. So the properties that are required were kept. The hardness was kept. The comfort factor was kept, low deformation, high resilience, and then reactivity and the molded density. All of that was kept, meeting all of the parameters. Okay, I think we had a glitch, but that's okay now. I'll keep on talking. Well, the next slide is a solution that we gave for a semi-rigid system for quebra-sol, replacing partially the fossil-based polyol by a renewable source polyol. It was a water-based system. We used a blowing agent that is ecological. Let's go to the next slide. So the ecological blowing agent was used, and the properties, they were all maintained according to the product requirements. So it has a great finish, a good hardness according to specifications, a good filling of spaces and cavities, and then reactivity and molded densities, they were both kept, they were both complied with. Next. Semi-rigid system for the automotive mat. It can be used for mats, but it can be used for the acoustic insulation and the engine insulation. But the mat is used in trucks in this case, and then in large vehicles like trucks. So in this development, we used renewable source polyol, reduced the fossil-based polyol. We used an ecological blowing agent, and the properties, they were all kept. So the hardness was kept, the finishing is excellent, there is a good fluidity and a good feeling of the product, a low deformation rate, and reactivity and molded density were kept. They all met the requirements. Next. The integral skin system for the steering wheel. So we replaced a share of the fossil-based polyol by renewable source polyol. We used an ecological blowing agent as well. And then the properties of the final parts, a great skin finishing, the toughness was respected, the hardness was respected, there was an excellent fluidity and capacity of filling, and molded density and reactivity, they were kept. They were kept for each of the clients. So here we have an example of an application in which we can use HR system polyol. It's a renewable source kind of polyol, so it's a ball. But other toys can be produced by using this system. So renewable source polyol was used in this system, reducing the fossil-based polyol. It is a water-based development, and the properties are excellent finish, excellent skin finish. This product can be sold without membranes, without top-up membranes. The molded density was 60 kilos per cubic meter, high resilience that is above 50, and low deformation rate. Next. Well, so we have this commitment with the UNDP for the reduction of HCFC in the foam sector. So we would like to inform that all of the traded systems that we use, they use ecological blowing agents. So you can see the picture of the application in rigid systems. So we underwent a conversion because of the United Nations program. It was a quite challenging work. So we were able to develop our knowledge during the conversion phase, and we would like to contribute to the industries and to the companies that are willing to do the conversion, because Amino does have in its portfolio all of the products that were used for the conversion: catalysts, silicone, special additives. So we are replacing 141B by HFO or other blowing agents. So we do have the technology available to do that. If you're interested, you do find my email, and then you may get in touch with us. And then we'll provide to you the technology that we used. Next. The molded viscoelastic system that is water-based. So that's a study case in which we compare the molded viscoelastic system, water-based, versus the physical blowing agent. So the weight of the final piece and the target is 750 grams. In order to attain this final weight using the physical blowing agent, we need to inject 865 grams. We need 13% of volatile loss. We have 13% of volatile loss. In the water system, we inject 792 grams in order to attain the very same target weight, 750. So there'll be a reduction of volatile loss. As you can see, it's just 5.54. So we have 2 drums of polyol, 1 of iso, totaling 650 kilos. So we used the physical blowing agent system. So it was possible to produce 750 pillows. With the water-based system, we were able to produce 820 pillows with the very same amount of raw materials, 650 kilos. So benefits. So we increased the productivity to 5.33%. We have a reduction of 8.3% in the purchasing of raw materials. It's a non-flammable, non-toxic raw material. And you can also reduce the transportation costs because it's a non-classified material. Next. Let me talk about the circular economy, the systems that we developed for that purpose. In our portfolio, we have different kinds of binders for foam. The AMG 13.2 is widely used in our segment. We sell this product quite often. So you can use this for tatamis, for mattresses, for automotive technical parts, and other applications. Next. So binders for rubber scrap. ground rubber scrap. So we have different kinds of glues for that purpose, to make it harder or less harder. But we have a MIPRI PB134 with this glue. We can do molded boards that can be used in playgrounds, in fitness centers, in CrossFit fitness center. It can be used as monolithic flooring when you want to use in large areas. Well, this is what you do in using the rubber plywood. For example, the athletics track or recreational parks. These are examples. A MIPRI PB137. So this system, this glue was developed, it's a binder, was developed for binding flip-flop sandals scraps. So by using a MIPRI PB137, we can provide a good binding characteristic to this product. A low density, high resilience product. The binder must have good tack, good binding properties, so you will attain a good finish in the end. And with the adhesive, you can do wheelbarrows, technical parts, and laminated blankets. Next. The binder for waste wood, for MDF, or even paper money for plywood. So we have a MIPRI PPS 2366, and that's a product that can be used to produce decorative pots, boards, furniture, and household items. So you might wonder, but the wood is a biodegradable product, but that depends. If it contains resin and it's treated, the wood is not considered to be a material that decomposes quite easily. So there are some residues in there that will prevent the good degradability. And there are some pieces of wood that receive such treatments with the resins. So a new purpose, these residues can be repurposed. Excuse me for 1 second. Amicati WCP 3900. That's a new technology. And that's tin used in fabric. It's a stannous neodecanoate, tin neodecanoate. It will replace the old one in some markets, the European and North American markets, because they have specific demands and no longer they allow the use of tin. And this can also be applied in the Brazilian and South American market. So what are the advantages of this material? It has a low VOC. It has no toxicity, no reproductive toxicity. So we need to increase by 15% the tin content in your formulation to have the same catalytic profile as the tin itself. So this new tin has 19% of tin against 28% of the stannous octoate. Next. Another solution that we introduced, Amipri PAX 2627. Let me go back and let me tell you a story about this application. Some time ago, the seedlings were grown and planted in nursery homes using this vase that was made of plant itself. So this posed a threat to the species, So in the 90s, this kind of natural vase went into the list of endangered species. The plant takes 20 years to grow 50 centimeters. So it's an agricultural segment. We use coconut fibers or palm tree fibers to simulate the xaxim, which is this natural vase, and then use some adhesive, some binder to put the fibers together. So we developed this hydrophilic binder that will put together the substrate and really hold it well. So it's going to be more permeable and aerated without losing properties. So it's ideal so that the plants receive the volume of air and water that are required for their development. And with that, we capped the final product as a biodegradable product. And this binder will not harm the plant. It's not harmful to the plant, so there'll be no issues with the plant if it gets in contact with the adhesive, with the binder. Well, that's the end of my presentation. Very nice to be able to talk for the African market. Thank you so much. And I'm here available to answer any questions that you might have. Okay, here I am. Tiago now can relax and drink some water. He talked a lot. He showed lots of interesting things to us. Excellent presentation, Tiago. Very, very good. It's a lot for us to unravel in the next few months in talking with you at Amino. So thank you again for participating one more. And if we don't see each other up until the trade show, the FEPLAR, and I'll go there and visit you at Amino to drink some Coke. Amino has beautiful booths at FEPLAR trade show, and they organize the forums beautifully in a quite elegant fashion. So I was there at the trade show. I was looking from outside. I looked at the booth, and then I took some pictures for Carla. She's one of the directors, to see whether she likes. So I brought her the idea of the other booth so that she can be inspired by new trends for booths. It's a very nice booth, and the forms are so well organized, aesthetically speaking, they're beautiful. So see you then at Amino's booth. So last year you had pinga. Pinga is the Brazilian sugarcane spirits. Yeah, that's for the tough ones only. But see you then. Thank you, Tiago. See you next time.